Hi everybody, thank you for joining us today. I'm Elsa Sklavounou, SYSTRAN Partner Manager, and I'm with Nafisa, who will pilot your questions throughout this webinar. I wanted to have this working session together in order to see how we can switch seamlessly from the rule-based machine translation system to a statistical machine translation system, and now to the pure neural machine translation system once available via SYSTRAN Enterprise Server, the APIs, and the SYSTRAN connectors. Before going deeper, let me present the agenda. We will very quickly have a brain warm-up related to the artificial intelligence, how it is applied to natural language processing, a brief history, the new era that is coming up, and the making of neural machine translation. And then we will dive deep to the subject of our webinar, which is what are the reflexes that we can have based on the content type in order to switch between the different technologies. We will have some use cases and proceed to the live demo. Afterwards, we will have an overview about SYSTRAN, and we can answer your questions and listen to your feedback. So let's start about the artificial intelligence and how it's getting applied to the natural language processing. As you see, we all know that natural language processing is tricky and complex due to the diversity of input, the document or the sentence size, the language structure, and the subjectivity of the content in more than 6,000 languages spoken in the world. The translation processes, as we know, before the artificial intelligence, they were mainly based on two technologies: the rule-based system, where we had a translation consistency as it relies on explicit human knowledge, and the statistical machine translation, where we get the translation fluency by training overnight on data the systems, leveraging massive amounts of data. In the first case, in the rule-based system, we all know the limits in transferring the pragmatic knowledge of the source sentence, requiring vast linguistic knowledge, and in the statistical part, we do know that we cannot generalize the rules, and there is lack of linguistic knowledge. Now that we have the new technologies, we can start talking about artificial intelligence, human augmentation, and SYSTRAN enhance now the understanding of the communication with secure end-to-end solutions, giving you access to the pure neural system based on neural networks. In fact, the artificial neural network is composed of different layers. We have the layers that are connected together with weights that we call parameters. The neural network is unique. It can automatically correct the parameters during the training phase based on the data. And then by sending corrective feedback to the engine based on the generated output and the expected output, we can give some automatically driven corrective feedback. Now, the neural networks that are used for natural language processing, they have 8 to 20 layers and what we call deep neural network. The making of neural translation very quickly, the encoding phase, where we have the encoding of the entire incoming sentence in order to build internal numerical representation. And then we have the decoding phase, where words are generated in sequence based on this internal representation of the word already generated. The three main ingredients, without going into details: a powerful language map thanks to word embeddings, a contextual knowledge thanks to recurrent neural networks, and attention capacity based on the attention models that where we know that the translation model is focusing its attention on words that it considers to be most important at the given stage of the translation. Now, how happens that artificial intelligence and neural networks enhance machine translation is because based on all the techniques that we have just seen, we produce a translation overachieving, and we know now that the output is better than a non-native speaker text, giving fluency and relevance. If you remember in the past about the rule-based system and the statistical systems, we always talk about fluency. Now that artificial intelligence allow us to talk about knowledge transfer, we can talk about relevance. We have the context adaptation that can be generalized, and of course, better terminology management. What are the benefits of all that? We have a higher generic quality and consequently less post-editing, and the applicability and the connectivity to new applications for communication purposes. If we go through the history, you remember we started in the 70s with a rule-based system. Here we see the common sense advisory chart about the curves in the history of machine translation. You see that the quality was pretty low in the 70s. In 80s plus 90s, we had the statistical MT and the hybrid MT starting every time the baseline in a higher level. But we do see now that the starting point of the neural MT is far higher than the others. Now let's go to the core of our working session, this webinar. I would like you to share some data in order to get some fast reflexes how to switch from one system to the other. The first part is let's see first the category. The reflexes that we have are based first in the segment length, second in the segment complexity, third to the technicity, fourth to the consistency, and the localization level. Let me give you some examples, and we are going to see the demo at the same time. Segment length. The shorter is the segment, the less appropriate is the PNMT. In fact, we are focusing on segments of web content, web applications, or software. Here, I just took the menus of a CRM based on the sales, and we do see that without any context, the PNMT is taking arbitrary for campaigns, campaign electoral, about the elections, opportunities, the possibilité, chatter, the bavardage, leads, the conduit, quotes, the quotations. We do see that there is no context that will allow the system to detect what we know intuitively with our brain. Nevertheless, if I go to my rule-based system, I do see automatically that I select the profile with a rule-based system, and I do see that the system takes into account the specific dictionary, the specific terminology, and is able to translate campaigns like campagne, opportunities, opportunité, chatter, chatter. Why? Because we can have do not translate items that we would like to reuse as loan words into French, leads, and codes. As you see, always you have the possibility to have the linguistic layer of the dictionary lookup so as to see for each word different associated noun phrases. If I go back to my example, let's talk about the complexity. Here we have a complex segment, which is the term industry 4.0, means a smart factory in which smart digital devices are networked and they communicate with raw materials, semi-finished products, machines, tools, robots, and men. If we see the rule-based system, you do see that the translation is completely obsolete, even if we do see that network that I underlined on purpose is being correctly translated. So we see that the complexity of the segment is a blocker for the RBMT, but we will see just after that the PNMT is far more adapted. So what I do is the only thing that I selected is I select my PNMT profile, and based on the neural networks, and I do see that my translation is perfect, even if the word network is missing from the neural lace of my English-French generic system. What do we see here is that finally the artificial intelligence and the self-learning of the PNMT allow us at the end to gain an artificial intuition and continue correctly the structure, even if it is a complex segment. Of course, I have the possibility with a specializable PNMT to go and introduce this term in a way that the function of this past participle is going to be applied. And in order not to gain that here, it was my other example. So I can select my self-learning PNMT, and while I will retranslate, I was supposed to see the good result. Let me go back to my other examples. The more technical is the segment, the less appropriate is the RBMT. So we have a segment where we have name entities, complex sentences, and also product names. You get the flexibility to deliver Windows Enterprise across devices through local install, virtual desktop infrastructure, VDI, or Windows to go. So what we see here is that we have, vous obtenez la flexibilité de fournir l'entreprise de Windows, a word-by-word translation after the source analysis, à travers des dispositifs par des gens du pays installés, which is a complete obsolete translation, analyzing the through local install, virtual desktop infrastructure, VDI, which is a product name, but it is getting analyzed as a free noun phrase, and Windows to go. If I go back to my system where I have my PNMT, I will see that here my PNMT, it has the possibility to identify the name entities. Vous obtenez la flexibilité pour livrer Windows Enterprise à travers les périphériques via l'installation locale. Virtual desktop infrastructure recognizes the name entity and the product, or Windows to go. The last criterion is also the consistency. I kept exactly the same example. Why? Because we can expect that a trainable SMT system on IT, as it cannot be generalized, you see that you get some better inputs, outputs than previously, but nevertheless, you have always the problem of the generalization of the IT domain in the given sentence. So even if we have a specialized SMT, it might be the case that we lose some information, like in the example, vous obtenez la possibilité de fournir l'entreprise de Windows. Here we keep only Windows as a name entity, but not Enterprise. Sur plusieurs périphériques via des variables locales installées. It's always very difficult to go through local install. And then we are getting virtual desktop infrastructure with a low case, or Windows to go, something that at the time being was not introduced in the trained data. You remember that our result with the PNMT, it's always better, even if it is the generic PNMT. The last criterion, which is very important, is the segment localization level. So the higher is the localization, the less appropriate is the RBMT or even the SMT. Remember, we want to gain time in post-editing. We want to gain time in knowledge transfer, comply with the authoring policy of our end customers. That is the reason why I took some pitches of well-known brand names, because I'm worth it, because you are worth it. A chocolate bar refuel, a pair of shoes is all in. I don't name the brands, but I want just to show you the highest localization level during the slogan authoring. So, the RBMT, puisque je le vaux, puisque vous le valez, réapprovisionner un combustible, which is completely the refuel, is all in, a word-by-word translation, et tout dedans. So, if I go back to my PNMT system, that now I have self-learned it with the authoring policy of my end customer, what do I see? I see parce que je le vaux bien, parce que vous le valez bien, my chocolate bar et ça répare, my pair of shoes don't too. At the right side, you have always the possibility to access to the dictionary lookup outside the pure neural machine translation system that you can specialize in a way that you have a quick view of the terms that you might see in the sentence, even if it belongs to different grammatical categories, the way we see with words. Here we know that it is a predicate, I'm worth it, but nevertheless, we have the possibility to have worth as a noun. And this is something completely outside the pure neural system, but it's for consultant purpose to have it at the right side. About SYSTRAN, just to give you a very quick overview of how we are standing since 1968. Now we are covering more than 100 language combinations. We have offices, the headquarters is in Seoul. We have now more than about 200 employees. 25% of SYSTRAN revenue is invested in R&D. We are working in research ecosystems all over the world with Harvard, NLP Group, LIMC, Aachen University, CNRS, ICAR, and 3, and involved in many research programs. CNRS gave us the distinction to be the leader in machine translation and natural language processing, and all that, let's say, blocks bring us to have a system where seamlessly you have access to the rule-based system, the statistical also, as well as the neural machine translation. How this technology is accessible for you, for the partners, for end applications, for service providers, and big corporate customers. We have two main solutions: SYSTRAN Enterprise Server for an in-house, secure, private data processing with no risk of leaking. And also SYSTRAN is found embedded in mobile applications in a way that you communicate while you are traveling all over the world. What is the next steps of the NMT tomorrow? Of course, the chatbots, the translation checkers, multilingual authoring, voice-to-voice, predictive translation, and language learning in a way that we achieve an augmented human communication beyond language. If I would like now to resume, I have an overview of the tips that we have seen together in order to switch to the right service based on the content that you identify. Don't forget to classify it by data consistency, referencing related to spelling, grammaticality, domain-specific consistency. The neologism and the not found words, we know that within rule-based or even statistical machine translation system, the analysis of the source segment is completely obsolete when there is a word that is not found. Nevertheless, the artificial intuition of the pure neural machine translation, which is specializable, give us a fluent content even if the word is not known, but it is, as we have seen with the word network, positioned in the right place in the sentence. Think about the rich coordination structures, multiple commas, multiple relative clauses that makes very difficult the word-by-word analysis throughout the rule-based machine translation. The statistical system not generalizable, the pure neural machine translation, always with the knowledge transfer coming natively from the data. And of course, the target localization level, the more you want to go outside the source sentence, the source segment, the more you would like to be able to rewrite it so as to proceed to an authoring based on editorial policy and gain time in the authoring process. So that's all what I would like to see together. I would like you to see how SYSTRAN with a single product gives you access via the APIs and all our connectors, no matter if it is the CAD tools, TMSs, e-discovery tools, or third platforms for media monitoring, text mining, data mining, allowing you with a rule-based system to go fast, trigger the data, exclude the ones that are not consistent to what you are looking for, and then proceed to the translation via the neural machine translation so as to acquire neurally the data knowledge. So I don't know now if you have questions. I will be glad to answer to them.
We have a question from Lara. Is it possible to specialize in neural MT?
Yes, exactly, Lara. We have many ways of two levels of specializing the pure neural machine translation. The first one is from the terminology, where words now represent functions, and we can replace one word in the function of the other. And of course, you can plug always your translation memories. And in case you would like to have your own data brain, it is also possible to create a data-specific neural machine translation model. I have also a question from Evie. Is okay, the voice-to-voice. We are working, we have already the speech-to-text, and you know that we interact already in mobile devices where we can revocalize the text, the translated text. So we keep you, the blog of SYSTRAN is always up to date. There is always a notification about the technology, and I will be glad to give you the roadmap for the end of the year. In fact, Paulo is asking us if we have already customers in production with PNMT. Yes, we are very happy to have one of the biggest pharma customers in Europe that they are running on the PNMT, and also we have 3 finance customers that they have implemented the PNMT in-house. So how far is getting the voice-to-voice? In fact, you know, the voice-to-voice is getting far in a sense that we don't have anymore the, let's say, the bottleneck of the quality of the transcript. That means that in a certain way, implementing the deep neural network allows you, based on the attention model that I have covered very quickly in order to switch to the demo, allows you to learn differently the voice-to-voice without having to go through the text. So if you see what's happening in music, if you see what's happening in image or the generators, you do understand that a voice-to-voice generator is going as far as the artificial intelligence allows. And as you know, artificial intelligence brings us very far. Another question? Thank you, Evie. Of course, I covered very quickly the connectivity of to SYSTRAN Enterprise Server in-house via the CAD tools. You do know that all the CAD tools and the TMSs have an entry for machine translation, and all you need to do is just give the reference URL of your SYSTRAN Enterprise Server and select the corresponding profile to the layer that is appropriate based on the reflexes that now you know that you can have in the system. Laurent is asking me if I can perform real-time complete HTML pages. Yes, absolutely. And I used the text translation before in order to concentrate to the reflexes that you have. And you have in the menu of the translation tools that are available, you have the possibility to attach a bookmarklet or even a translation widget to your website or to the HTML pages in order to translate them on the fly with the neural technology. So not only it is a real time, but it's also complete in the sense that you have the full fluid navigation every time you click in one link. Rajan is asking me that in case it is the best technology, why is the tool giving options for previous versions? Ah, perfect. That's perfect, Rajan. In fact, the reason why we wanted to keep the older layers is because the older layers have still some benefits. Let me explain what are the benefits. The first one is the time you wait for a translation, the performance. If we take into consideration that you would like to have fast in some industries like the media monitoring or the data mining, you want to, in a certain way, sort out the data that are, first of all, linguistically consistent. Linguistically consistent means that you would like to avoid the processing data that are useless for your purpose. And then you would like to get the knowledge coming from the data once you had filtered them very quickly with the rule-based layer. The statistical machine translation is when you have a very specific technical domain where you do know that the statistical machine translation model is the one that is completely modelized on this tiny technical jargon you have, because absolutely you don't want to generalize the knowledge. Whereas the PNMT, it has this knowledge and this competence that is generalizable, whatever the content is. We have seen it with my examples. I had a generic IT text. The generic IT SMT cannot do the work of a generic pure neural machine translation. On the other hand, think about that if the pure neural machine translation that SYSTRAN is offering to the users, if it is specializable, is because it has the layer of the rule-based system which allows to interact by words and now plug them to functions. So that is the reason why we would like to keep all those layers available. Laurent, yes, with pleasure. We can have a POC together anytime you wish, given the scope of your project. Peter is asking me about the comparison of the hardware and processor going from SMT to NMT. It's very interesting as a question. Now, the main, it is not related. You remember there are SMT, statistical machine translation models that are taking a huge amount of RAM sometimes to load in memory in order to proceed the translations. In fact, with the PNMT, we don't need so much the memory, but the cores. So basically, in a single, I'm not too technical, you know that, but I can give you just a very generic information, and I will be happy to share with you the hardware requirements. A statistical machine translation is covering two cores. The PNMT is using 4. So that's the main difference. And we are talking always about a machine in CPU, which is very important. Okay, we are using GPU in order to generate a neural machine translation model, but we can run it on a CPU-based servers using per language orientation 4 cores. Of course, if you have a machine with a GPU, of course, you can run all the layers that we have seen together. So thank you so much for joining, and hope to see you soon, work with you like that in the future webinars today together. Bye-bye. Thanks again.